Welcome back. Bill Witte here with more pre-algebra. You know what you're going to find out today? This stuff is downright useful. And you know what else? As we move further and more advanced in mathematics, it becomes even more useful. Okay? And as you go to the more advanced classes, it becomes even more useful. You're going to love this. Okay? I hope to show you that. Now don't forget, we've got, if you have trouble, that you can go to your good old buddy, the homepage at www.montgomerycollege.edu/pre-algebra. Okay? Hey, what do we got today anyway?
Holy heart failure!
Oh, we're going to be converting from three things: percents, decimals, and fractions. Okay, well, the only new one is is percents, okay? We had covered the other things before. Maybe we should review. You remember what we covered last time? Let's take a look. We talked about decimals and what makes them. The whole number part, the digits were the ones, for instance, the tens, the hundreds, the thousands, and so on. And then the other part, the fractional or decimal part, the digits were tenths, hundredths, thousandths, and so on. Okay?
Do that again.
Well, when we're going to use the digits now to round. Remember when we rounded to whole numbers, like round to the nearest thousand? Every number after that had to be a zero. So this one would round to the nearest thousand would either be 267,000 or 268,000. How did we know which one? We used the next digit to judge.
Are you pondering what I'm pondering?
And the next digit, if it was 0, 1, 2, 3, or 4, we'd stay at the same number, and if it was 5, 6, 7, 8, or 9, we'd go up. So in this case,
You're way off. I say you're way off.
we don't use that one.
time,
We're going to
son.
stay with the 267,000. Okay? Now, what did that have to do with decimals? Well, we can use the same deal when we round to decimal numbers, like tenths. Okay? Let's round this bad boy to the tenths. Now, where was the tenths? Oh, yeah. Okay, that's the tenth spot. That means everything after it can be a zero. And actually, remember in decimals, you could dump the zeros at the end. So this one is either 156.8 or 156.9. Now, just like before, we use the next digit
Perhaps I could be of some assistance.
to decide which way to go. Now, in this case, 2 being so small,
Oh, he got all of that one.
the answer is 156.8. Note we dropped the 0 because we didn't need it, okay, at the end of a decimal. Let's do another one.
Thank you, sir. May I have another?
In this case, we're going to round to the nearest hundredth. Now, you have to know your digits. There's the hundredth digit, okay? That means everything after it can be a 0 or basically can be dropped. So we're looking at either 267.36 or 0.37. What do we use to decide?
Are you pondering what I'm pondering?
The next digit. And that, once again, in this case, it happens to be a lower number. So we use the lower. 267.36 is your answer. Okay?
Now what am I gonna do?
Useful stuff. Okay? Now, what else did we do with decimals? Well, rounding to the nearest whole. Okay? It's easy. Just remember that wholes
Now what am I gonna do?
is the ones digit. Okay? But the same rule will follow. We're going to drop everything after that. Okay? We just pick which number. Use the next digit,
Perhaps I could be of some assistance.
which in this case, we're going to go up, aren't we?
Yes!
So the answer is 2,674. Now, you could say 2,674.0, but the whole point of it was to end up with a whole number. Okay? So we drop the 0.0 and just say 2,674. Get the idea? That's rounding to the nearest whole.
Now look at here.
Oh, and why do we do this? Well, sometimes we're going to ask for an estimated sum. Now, don't be adding them up and then rounding, okay? The idea is to make the problem easier. So let's round first.
I can do that, but I don't want to.
Right. So let's round to 29.4 rounded to the nearest whole is about 29. We go down that time. 6.13 rounded to the nearest whole is about 6. And then lastly, this one rounds to about, oh, it's higher, so we go up, rounds to 17. Well, now it's much easier to add. And we've got a much, closer estimate anyway. It is an estimate because the other one is 52.24. But you know what?
Missed it by that much.
We're pretty dad-burned close, okay?
Go!
And certainly when you're adding things, you want to be pretty close, especially when you're talking about mileage.
And another thing.
Now, we could use this rounding to estimate a reasonable answer here. If you were on a test or whatever, you would check your answer, and if you're too lazy to check your answer, you'd check to see at least if your answer is reasonable. Well, let's see if they gave you a choice. You knew it was one of these, okay? Well, this one rounds to about 1, and this one rounds to about 3. And I can multiply 1 times 3 easily. So the answer should be about 3. Now, which one's about 3?
Maybe this is it. Not.
No,
Not.
not this one. The only possible reasonable answer, even if you were too lazy to multiply it,
You're absolutely correct.
is this one. Okay, so we can use this on tests too. Check to see if your answers are even reasonable. Got the idea? Okay. Let's check it. 6 times 3 is 18. Carry the 1. 3 times 2 is 6. Plus 1 is 7. And then 1 times 6 is 6. 1 times 2 is 2. We add them up. Now remember how to we're going to add them all up. And how to multiply decimals. Now we have to count. Take that number and count however many decimals are in the whole problem. In this case, 2. So we're going to move over 2 decimal places.
That's the fact, Jack!
And we got ourselves an answer. Okay? So we were right.
Well, this is all very sophisticated.
What about fractions? We had talked about fractions before. We needed to know the words. In this example, we demonstrated to you
I have been chosen.
the fraction was the numerator, the top of it, was the amount of pieces that have been chosen over the total number of pieces we called the denominator. So the top, in this case,
I have been chosen.
3 over the denominator, 5, the total number of pieces. We had a fraction you're looking at is 3/5. You got to know the right words, okay? There are other words involved with fractions because fractions really are a division problem. In a division problem, we got 3 things going on here. We got the guy getting divided, the dividend, the guy doing the dividing, the divisor, and the answer, the quotient. Even if it looked like this. We got the guy doing or getting divided, the dividend, the guy doing the dividing, the divisor, and the answer, the quotient. Now, what does this have to do with fractions? Well, a fraction, son of a gun, is a division problem with an answer.
Shazam.
Possibly. And if you reduced it, same deal. The guy getting divided is the dividend. The guy doing the division, still the divisor. And the answer could be called the quotient. Okay, so get the idea that a fraction is a division problem.
Yoink.
Okay, now if I want to write a fraction as a decimal, all we do is that division problem. Divide the numerator, the top, by the denominator.
Well, ooh-la-dee-da.
It's easy.
I have a feeling some bad stuff is about to go down.
No, it's not. It's easy, okay? For instance, if we wanted to change 1/4 into a decimal, we go 1 divided by 4. Now we do have to bring in some decimal points, okay, because we need some spaces. Well, let's see. There we go. 4 into 1 goes nonce, so not a factor. 4 into 10 goes twice, okay? So we estimate, multiply, and subtract, just like before. Okay, let's bring down the next digit. Estimate, multiply, and subtract. I'd bring down the next digit, but it came out to 0.
Yeah, baby. Yeah.
So I got myself an answer.
What have I done to deserve this?
Now there can be a little bit more involved with this. Let's do another one and consider this one. Still, I'm dividing the top by the bottom, or the numerator by the denominator. 2 divided by 3. Now once again, I'm going to need some decimals. Okay, let me throw in a couple zeros. I could throw in more if I wanted. Place that decimal where he's supposed to be, and let's do some division. 3 doesn't go into 2. Okay, how about 3 into 20? About 6. Okay, multiply, subtract, and bring down the next digit. Okay, let's see, it didn't come out even, so let's try it again. Re-estimate. 3 into 20, multiply, subtract, and bring down the next digit. Well, there wasn't a next digit, but you could say it was 0. Okay, we could go on and on and on. Multiply, subtract, bring down the next digit. Oh, this could go on and on and on. How far could it go, by the way?
To infinity and beyond.
Oh, so now what are we going to do? Well, do you remember what we did with the repetand? We put a bar over what was repeating, and actually what's repeating in this case is a 6. So the best answer here is going to be 0.6 with a repetand on it.
Brilliance. That's all I can say. Sheer, unadulterated brilliance.
Get the idea?
Do that again.
Okay, we'll try one more. 3 divided by 11, numerator divided by denominator. Okay, throw in some, no, I threw in 3 that time just for good measure. Put down your decimal and let's try it. 11 into 3, no, how about 11 into 30? Okay, twice, so 2 times multiply and subtract. Bring down the next digit. Okay, let's re-estimate. 11 into 80. Multiply and subtract. Okay, bring down the next digit. Okay, re-estimate. 11 into 30. I remember 30. Multiply and subtract. Bring down the next digit. Well, we don't have a next digit, but we can make one. We'll use a 0. Okay, re-estimate. I remember 80. Multiply. You see it's starting to repeat again, isn't it? Okay. What's repeating in this case? And how far will it go?
To infinity and beyond.
Well, what's repeating? Not just the 2, but this time a 2 and a 7. So this time we're going to use our repetand over the part that's repeating, the 2 and the 7. And our answer will be 0.27 with a repetand over it.
Marvelous. Yes, indeed. Simply marvelous.
That's about as hard as it'll get, okay?
Hey, this is great, man.
Remember the idea of quick multiplication and division with powers of 10. For instance, in this case, I want to multiply by 100. Okay, so I'm going to move over how many places in this case? It's multiplication. I got 2 places. So I'm going to go 2 to the right. You know why I go to the right? Because it's going to get bigger. And I got myself an answer. That was quick, huh? Didn't have to go through all that multiplication. Now in this case, I have division.
Code red. Repeat. We are at code red.
Still going to move over how many places? 2 in this case. The only difference is it's going to go the other way. It's going to get smaller because division makes it smaller. Put your decimal there, and you got an answer. Pretty easy, huh? Here's another division.
Oh, right, guy.
But this one's only divided by 10. How many zeros? Just 1. So that's how many places we'll move over. And you got yourself an answer. It's easy, sleazy. How about this bad boy? It's multiplication. We got how many zeros? 3. Get the idea? I'm going to move over 3 places. And you have an answer. Do we really need that decimal point when we have a whole number like this? No, we don't. So we don't put it. Okay? One more. In this case, we're dividing.
Mayday, Mayday, come in, Star Command.
It's
Send
not hard.
reinforcements.
By 3 places. We'll move it over. And you got yourself an answer.
Baby. Yeah.
Now this was a nice little tool when doing those computations, but it became even more useful when we solved equations with decimals in them. Remember how we did that? Let's take a look.
There's something wrong with us. Something very, very wrong with us.
That equation has a decimal in it. What are we going to do? Well, the secret is get rid of it first. Find the highest decimal power, and in this case it's 10, and multiply everybody, because it's got to do it to everybody, by that power. And of course when we multiply, we just move the decimal over. Let's take a look. In this case we get 70y. Note no decimal. In this case, we just move the decimal over, because we're multiplying by 10 with 1 0.
Yes.
And the decimal's gone. Of course, we got to do it to everybody.
I make this look good.
And now we're looking goony goo goo, and we just solve normally. Let's see. I'm going to subtract a 70y from both sides. And then who's keeping y from being alone? The minus 40, so I'll do the opposite, divide. And I got an answer of minus 6 1/10.
Excellent.
Okay? Now there's one screwy thing that can happen.
Yes, you're in deep dough now.
In this case, I've got
Excuse me,
a
Professor
decimal to the
Brainiac.
10th and a decimal to the 100th. Well, let's use the biggest one, and I promise you it'll clean up. So the 100's the biggest one. So let's multiply everybody by 100. Okay? Now in this case, I don't have 2 places to move it over, so I'll need to make a place. Remember? No problem. And I get 40x. If you don't have one, you make one. In this case, it's easy. I move it over 2 places, and it's not a decimal anymore. In this case, I move it over 2 places.
Marvelous. Yes, indeed. Simply marvelous.
And I don't even need the extra 0 at the end, do I? In fact, I don't want it, okay? So now I solve it normally. Who's keeping x from being alone? Let's get rid of that 72. Do it to both sides. Okay, now divide by 40. Both sides. And we got an answer.
Genius. That's what it is. Sheer genius.
Now that's what we covered last time. How about something new? You know what we're going to cover today? We did last time decimals and fractions. We're going to throw into the mix.
This is an intergalactic emergency. I need to commandeer your vessel to Sector 12.
We're going to throw in percents. Do you remember
Do that again.
that a fraction is the numerator over the denominator? In this case, 1, the chosen, out of the total number, 4. Well, let's talk about the new thing, percents. Percent means,
No way.
yes it does, a fraction out of 100. You don't believe me, a fraction out of 100. They actually took the number 100
Allow me to demonstrate.
and they took the number 100 and made a fraction out of it.
It is alive.
With a numerator and a denominator, and that's where the symbol came from. I'm swearing it is, okay? And I'm sticking to it anyway.
That's the fact, Jack.
Percent means fraction per cent out of 100. Get the idea? Per 100 or cent or century, okay? It really does.
But now you know the rest of the story.
No, really it does, okay? Anyway, consider that the whole time, because that's going to answer a lot of questions, okay? Well, let's start switching things. How do we write a decimal as a percent? Well, 45 100ths, we need to write it a fraction out of 100. Now that's the 10th digit, and that's the 100th digit. So let's write it per 100.
Oh.
Put the decimal place here. or read it, and you get 45/100ths. And 45/100ths as a percent is, that's what percent means, fraction out of 100. So if you can change these things to a fraction out of 100, you can just add your percentage, right? Now this one, out of 100. Where's our hundredths place? Oh. We got to write it out of hundredths. So we put our decimal place there. And what we have here is 125/100ths, known downtown as
Shazam!
125%. So if you can get it into hundredths, you've got it into percent. How about this bad boy? Well, that's where the hundredths would be, right there. So that's where our decimal place will be. 1.3/100ths. So that's how many percentage.
Hey, this is great, man.
Not so bad, is it? Basically, we're just moving the decimal place over 2 places, aren't we? But we're trying to do whatever it takes to make it into hundredths. Okay, let's work backwards. How do we write a percent as a decimal? Let's see, 53% really means percent out of 100 means percent out of 100. So let's replace that percentage sign with a division by 100, because that's what it means. Division by 100. Move it over 2. When we divide by 100, don't we move over 2? And 53% written as a decimal is 53/100ths, or 0.53. Just always move it over the other way, right? How about 4.6%? Well, percent means out of 100. So how would we write this out of 100, or divide by 100? We would move the decimal place over 2. We had to add 1 to move it over 2, didn't we? So we end up with 0.046. Okay, that's 4.6% written as a decimal. Get the idea?
And another thing.
Now, let's go another way. Let's write a percent as a fraction. Now, this one's easy. 40% written as a fraction. You remember what percent means now. Percent means per 100, or out of 100. So that's just 40 out of 100. Oh, we have to reduce, for cripe's sake, of course. In this case, reducing, dividing by 20 over 20, known downtown as 1. And 40% would be 2/5.
Cool.
Okay? Let's reduce this bad boy. Change him to a fraction. Let's see. 3.7% means 3.7 out of 100, with a denominator of 100. Okay, well, we're not allowed to have a decimal in a fraction. Okay, so we'll have to get rid of that.
Houston,
How are we going to get rid of that? We're going to have to move the decimal over 1, so we have to do the same thing in the bottom. I'm going to multiply top and bottom by 10, and I'll be looking good. 37/1000ths. Get the idea?
You are correct, sir.
All right.
Wait a minute.
What about 100%? How would you write that as all these things? What the heck is 100%? As a number, as a fraction, as a decimal? Well, consider, of course, the same thing. Percent means per 100. So I hope you know that 100%, with 100 as a denominator, 100 over 100, what is 100 over 100?
Is that your final answer?
No, you have to reduce. Dividing, I get. So 100% is the number 1.
That's the fact, Jack.
And that is worthy, I'll tell you, of memorizing, because you're going to get confused knowing which way the decimal should go. 1 is 100.
And you're going to do it because I said so.
I'm telling you, memorize this, okay? That way, if you want to change something...
You are correct, sir.
Yeah, remember 1 is 1.000, okay? And that's where the decimal place would be for the percent. Now, the problem is people forget which way to go. They know they go two places. Do they go two to the left or two to the right? And I always write out 1 is the same as 100%. Of course, 1.00 is a decimal, and 100% is a percent. And if I'm trying to convert to a percent, I can see, if I write this out, that I have to go to the right. My decimal place went to the right because I wrote out 1.00 is the same as 100%. Of course, if I need to change to a decimal, I can see that I need to move to the left. Okay? So that's how I remember it. 1.00 is 100%, and then I figure out which way I should go. I always know I should move two places. Okay? Okay, remember your old buddy, the multiplication property of 1?
I say, old chap.
What was that? You can multiply anything by 1 and get itself. 5 times 1 is 5. X times 1 is X. Hooga woo times 1 is hooga woo. Anything times 1 is itself. Now what does that have to do with the price of eggs here?
Oh, let's get ready to rumble.
Well, we're going to write a fraction as a percent. Ooh, a fraction as a percent.
Let's play. Here we go.
9/20 as a percent. What do we have to do to make something into a percent? Well, I'm going to multiply. I know I can multiply it by 1.
That's the fact, Jack!
And I know 100% is 1. I told you to memorize that. So let's, instead of multiplying 9/20 by 1, which I'm allowed to do, I'm going to multiply it by what 1 is. 100%. And reduce. Let's see. Of course, he's in the top. Let me cancel. 20 cancels with 100. 20 goes into itself once and into 100 5 times. So I'm looking good. 9 times 5. And I've changed, incredibly, I've changed 9/20 into a percentage, 45%.
Survey.
How about this one? 2/5 will change into a percentage. Well, let's see. We're going to multiply by your old buddy 1. But what is 1?
You look marvelous.
100%. So 2/5 times. I told you to memorize that. Now, of course, canceled if we can. 5 goes into 5 once, into 100 20 times, and we're looking at 2/5 being 2 times 20, or 40%.
Bring it on.
Okay, how are we going to do this bad boy? Holy, go to war. Well, I'm going to change him into an improper fraction first. 1 times 2 plus 1. It's got to be a fraction, and then multiply by 1. Or really multiply by what 1 is, 100%. Okay, can I cancel? In this case, got to reduce. 2 into both. So apparently 1.5, 3 times 50, it's 150%. This isn't that bad if we just memorize that 1 is 100%. It's going to help us a whole lot of times, okay? Not just this time. Okay, here's your summary. To change a percent to a decimal, you drop the percentage sign and divide by 100. Or in other words, to go from a percent to a decimal, you're going to move the decimal point 2 digits to the left. Remember when we divide by 100, we go 2 to the left. Okay? To go decimal to percent, you're just going to read the number with the decimal moved to the 100th digit. Okay? And then attach the sign. To go from a percent to a fraction, you're going to write the number part over 100. And then, as always, we have to reduce if possible. And to go from a fraction to a percent, you're going to multiply the fraction by 1, or as we said, by 100%, and then reduce if possible. Get the idea?
And now, ladies and gentlemen, for our next attraction,
let's work with, percentage equations. Holy, go to war. Well, this is so useful. Here's where you're going to see how useful this stuff is. Okay, but you know what? There's a little trick we'll show you before we start.
Just remember that this thing
Okay, we're going to use what I call the English to Math Dictionary, kind of like an English to Spanish dictionary. You're going to use it for conversions. You don't got to memorize the whole dictionary. Just 3 groups of the interpretations, and they're going to take you
to infinity and beyond.
Well, at least they're going to take you an awful long way, okay? And here they are. Anything that looks like the word what, or maybe how much, or any kind of a question like that, is going to interpret to
You never know what you're going to get.
a variable. Now, you can use any variable. It doesn't matter what letter. X, Y, A, doesn't matter. Okay, so that's what they're going to interpret to. Now, verby type things like was, or is, or would be, are going to interpret to, I bet you know, equals. Okay? And finally, of, on, that's about all you're going to see, are going to always, you love always, interpret to multiplication. Okay? And knowing those 3 things,
Allow me to demonstrate.
we can get a lot, we can actually get an equation out of just anything with percentages. For instance, what? Well, let's see, we need to convert that. I told you that converts to X, or some letter. Is converts to equals. Now, 6% is already in math language. Okay, so we can just write that. Of, remember what that was? Times, and then 4550, it's already in math language. It's already math. Okay, now we got ourselves an equation, and we can hopefully solve it. Let's see, 6%, it's going to be easier here to write that as a decimal, and 4550 as a decimal, and then do your multiplication. Okay, I'm hoping you know how to do that multiplication. I'm not going to review it here. We move the decimals over, and I got myself an answer.
Hey, this is great, man.
Okay, the hard part for most people is interpreting the original question into an equation. Once they get the equation, they can do it. So, now consider this one. Just in case you forgot how to multiply those 2 decimals, okay? We're going to multiply the decimals as though they were whole numbers. How do you do that? As if they were whole numbers. Forget the decimals altogether. And then take the answer and move the decimal place over the total number of places in the problem, which in this case is 2. Okay, so I'm going to expect you to know how to do that, okay?
Genius.
That's old
That's
material.
What it is. Sheer genius.
Okay, let's get back to our word problems.
Yoink.
How about this bad boy? What is 15% of 2550? This would be great at the store or at the restaurant, you people that leave 15% tips, okay? Well, let's see. What? That's going to be X is equals 15%, already in math language, of, you love this, times, and 2550, already in math language. So we can answer our question, you know, all we have to do is solve the equation. Well, let's see, let's turn 15% into a decimal. I have to move the decimal over 2 places, remember? Okay, and we'll multiply, and X will be, he's already by himself, so you're going to have to leave a tip of $3.82.5. Boy, you're a cheapo.
Oh, what a jip.
Give him a little more, please. That's good enough. Give him a close, give him 4 schmacks, okay? But you get the idea how to answer that question.
Well, thank you very much.
Okay, let's look at another one.
Now what am I gonna do?
Well, in this case, we're trying to figure out the opposite. 312 is 75% of what number? Well, not a problem. Let's use our interpretations. 312, that's already in math language, is, this is equals. 75% already in math language, of, how does of? Times. And what number? What? I'm going to use x. Okay, don't be confused with the multiplication and the x. Okay, I could have used a or b too. Okay, now we got to solve this baby. Okay, well, let's see. 75% as a decimal is 0.75 times x. Now I got to get x by itself. So what am I going to do? Divide both sides by 0.75. Ah, and doing the division, x is 416. Son of a gun.
Excellent.
Not so bad, especially not so bad to come up with the equation, is it? Uh-oh, I bet you forgot how to divide decimals, didn't you? I jumped over that. Let me remind you. Remember how to divide decimals? Well, let's see. We have to take the divisor, and it has to be a whole number. So in this case, I'm going to have to move the decimal place over 2 places to make that divisor a whole number. Of course, if I do it to the divisor, I have to do it to the dividend. Okay? Now let me spot him before I forget it. And now I just do the division normally, okay? Just in case you forgot. That's 5 into 22 goes 4 times. So let's see. Multiply, subtract, and bring down the next digit. Okay? Let's re-estimate. 5 into 25 goes 5 times. Multiply, subtract, and bring down the next digit. But it came out even, and we don't have a next digit anyway, so I think we got ourselves an answer. And I think you remembered that also anyway, okay?
How about a little fire, Scarecrow?
Okay, here's a totally different problem, but our same 3 interpretations are going to work no matter what. Now, 125 is 40% of what number? Let's see. 125, already in math, 125 is equals 40%, already in math language, of, remember your old buddy of, always converts to times, and what number? It's going to convert to a letter.
You never know what you're going to get.
Any letter, really. Okay? Well, let's see. Write that as a decimal. Now, I got to get that blue x alone. Okay? What's keeping it from being alone? The 0.40. He's multiplying.
Wait a minute.
So I'll divide. Got to do it to both sides. I'll cancel here, and 125 divided by 0.40, I just reviewed decimals, division, so I'm hoping you know how to do it. So in this case, doing the division, x is 312.5, or 0.50.
I'll take it.
Okay, these are nice little exercises to be able to do, especially at the store when you're checking the sales. Okay? Here's another one, a little bit different. Now we're asking what percentage on $70 would be $10.50? What percent of now if somebody says you get $10.50 off, you may want to know, geez, what percent did I get off? Okay, how could we figure that out? Well, what? That's any letter, right? Percentage, already in math language. Just write percentage. On. On smells like of. It's times. 70, already in math language. Would be, could be, schmould be. Always interprets to equals. And then finally, this one's already in math language. Now we got to solve this bad boy, okay? So I got to get x by itself. Well, let's look at this. Who's keeping x from being by itself? 2 troublemakers, the percent and the 70. Let me get rid of the 70 first, okay? Dividing by 70, I'll cancel, and I'll get x percent is the same as, now do your division. I trust you to do the division. 0.15. Now, what percentage is 0.15?
Wait a minute.
Remember how to do that? What a percent means? Fraction out of 100? What percent is 15/100ths? Well, that's the definition of percentage. 15%. 15 out of 100.
Baby, you're the greatest.
That's not so bad, is it? Now remember, writing a fraction as a decimal, you're just going to divide the numerator by the denominator, okay?
Well, ooh la dee da.
Well, just in case you forgot that.
I have a feeling some bad stuff is about to go
Not
down.
a problem. Well, I'm going to show you why I reminded you of that.
Now I say look at here.
To change 2/5 to a decimal, remember, we just divide the top by the bottom. Let's see. 5 into 20, 4 into 2 goes nonce. 5 into 20 goes 4 times. Multiply, subtract. We got ourselves an answer. Now.
Do that again.
Okay, we'll do it one more time. 1 divided by 4. Add some decimals. Okay. 4 goes into 1 nonce. 4 goes into 10 twice. Multiply. Subtract. Bring down the next digit. 4 into 20. 5. Multiply. Subtract. You're hunky-dunky.
Yeah, baby. Yeah.
Now, consider that, and let's try this baby. This is a tough one. What percent on 80 would be 68?
You never know what you're going to get.
That's going to be a variable. Percent we just write. On, remember what on is? Okay, 80 is already in math language. Would be 68, already in math language. Okay, so why did we cover that before? Well, let's see. Let's get rid of the 80, dividing both sides, because we're trying to get that x by itself. Okay, now that's what we were talking about. We've got to divide 68 divided by 80. And we get 0.85, okay? Now, what percent is 0.85?
Wait a minute.
Remember what the definition of percentage is? Fraction out of 100. 85, 0.85 is 85/100ths. So the answer is 85%.
Woohoo!
Not so bad, huh?
Thank you, sir. May I have another?
Okay, one more. So you'll see, geez, these are easy, okay? 37% of $300. Now, suppose you were getting a 37% discount and you wanted to know how much they were going to subtract. What's 37% of 300?
Well, ooh la dee da.
Well, this one's already in math language. 37% of times.
Well, ooh la dee da.
That's already in math language. Is, very easy. What number? What do we do with what? Becomes a letter. Okay, we're ready. X is already by itself. All we really need to do is compute. 37% times 300. Of course, what we'll have to do with 37%
Wait a minute.
is make it into a decimal. Then multiply by 300, and we got ourselves an answer. Those multiplied, 111. We're looking pretty good. This isn't so bad, especially once you convert it, is it? Okay, now what did we cover again? Let's go over it. You might have forgotten. The new thing was percentages. And what does percent mean?
No way.
Yes, it does. It means fraction out of 100. I'm hoping you won't forget that they took the number 100
Allow me to demonstrate.
and made a fraction out of it. Son of a gun, it is a fraction.
It is alive.
Remember what percent means. Fraction
That's the fact.
out of 100. Percent. out of 100. Cent, century, 100.
But now you know the rest of the story.
Okay, now remember that. Now, we had all these conversions we had to do. How do we write a decimal as a percent? For instance, this one. Well, to write a decimal as a percent, we need it to be a fraction out of 100. So we need to look for our hundredth spot, not our tenths digit, but our hundredths digit, always the second one if you would. Okay, and we've got to get the decimal point after the hundredth spot.
Oh.
Okay, so we put it there and divide by 100, and we've got ourselves a percentage.
Oh, gnarly!
There's your deal. Okay, so basically we're moving the decimal place over 2 places. In this case, we're going to move it over 2 places to the hundredth spot. So we have to do out of hundredths. Remember, where's the hundredth spot? So we're looking at 125 100ths, or remember, a fraction as a decimal. 125%. Okay? One more. Okay, we're going to move it over 2 to the hundredth spot. There it is, the hundredth spot. Okay, and we're going to have 1.3 100ths. Normally it would be a problem to have a decimal in a fraction.
Hey, this is great, man.
But we just add the percentage thing and we can have 1.3%. That's hunky-dinky. Now, to write a percent as a decimal, we're going to do basically just the opposite. We're going to move the decimal place over. Because remember what that percent sign means. Means out of 100, or divide by 100. Remember how to divide by 100? Move the decimal over 2 places. It started there, and we'll divide by 100. Go back 2 places, and now we've got ourselves a decimal. So when we're dividing, of course, we're getting smaller. So now it's a decimal. How about this bad boy? Let's make him into a decimal. Okay, out of 100, so we're going to do division by 100. We know our trick, dividing by 100, was to move that bad boy 2 places to the left. Starts there, and goes back 2. We don't have 2, so we had to add 1. And we got ourselves a decimal, 0.046. That's 4.6% as a decimal. Not so bad. What about writing a percent as a fraction? Remember, well, we have to remember what 40% means. It means that number out of 100. 40 out of 100. Okay, so we've made it into a fraction. Our only problem is that we always have to reduce. Okay, remember how to do that? Divide the top and bottom by the same thing. In this case, 20. Okay, 20 over 20 is 1, and you're allowed to divide 1 anytime you want. Now we have a nice reduced fraction. Cool. And that's what 40% really is equivalent to. How about 3.7%? Remember, we have to write percent as a fraction out of 100. Right? So we just put 100 as a denominator. Now this is not legal in this case, since we can't have a decimal in a fraction. So that's all right. We'll clean it up by multiplying the top and bottom by...
Houston, we have a problem.
Not a problem. We'll multiply the top and bottom by 10 to move that decimal over. Okay, that'll move it over to the other side of the 7. Of course, we have to do it on the bottom, too. And we get 37 1/1000ths.
You are correct, sir.
Okay, so we've taken a percent and changed it to a fraction.
Uh-oh.
Remember about 100%. If there's one thing you're going to memorize in percents, it's that since percent means per 100 or out of 100, 100 out of 100, 100% is equivalent to the number.
Is that your final answer?
If you reduce, it's equivalent to the number 1. Now this is very worthy of memorizing.
That's the fact, Jack!
100% is 1. Now, you may not memorize it in that way. A lot of people like to memorize it that 1...
And you're going to do it because I said so.
You're going to memorize 1 is 100%. Probably easier to see.
You are correct, sir.
If we see 1.00, that's what 1 is. Okay, where's the decimal for 100%, for the number 100, by the way? Oh, yeah. Okay, so there's a decimal in both. The reason you want to memorize it this way is because you want to know where that dadburn decimal is. Okay? So that when it's a decimal, or when it's a percent, you have to know which way to go. If I want to become a percent, I'm going to move to the right, as you can see. If I want to become a decimal, I'm going to move to the left. Get the idea? Okay, one more conversion. A fraction as a percent.
Let's play. Here we go.
Basically, we just multiplied by 1. Or, remember what I told you what 1 was?
That's the fact, Jack!
100%. So, we multiplied by 100%. It was, sometimes we had to reduce, and we had to consider that 100% is 100% over 1. But we'll cancel if we need to, and we got ourselves an answer.
Survey.
Let's do another one. Multiply by 1, known downtown as...
You look marvelous.
100%. Okay, put them under 1 if you need to, or over 1, but cancel. Dividing both by 5. And I got myself...
Yes.
Okay, remember, writing a fraction as a percent, just multiply by 1. Now this one isn't a fraction, it's a mixed number, so I'll have to make it into a fraction. 1 times 2 plus 1, 3/2. Now, I can multiply it by 100%. Cancel. Reduce. 2 into both. And I got myself, believe it or not, 1.5 is 150%. Okay? So in summary, to go from a percent to a decimal, basically we're going to drop that percentage sign and divide by 100, or move the decimal place 2 digits to the left. Okay? To go from a decimal to a percent, we're going to do just the opposite. Okay? We're going to move the decimal 2 digits to the right, and we're going to attach the percentage sign. Okay? To go from a percent to a fraction, we're going to write the number part over 100 and reduce if we need to. Okay? And as we just said, a fraction to a percent, we're going to multiply the fraction by 1, known downtown as 100%, and once again, reduce if needed. Okay? There's your 4 possibilities.
Remember that this thing isn't as black as it appeared.
Remember when we were working with percentage questions or equations, we used the English to Math dictionary, which we equated to 3 groups of interpretations.
To infinity and beyond.
It took us all the way if we knew that any kind of a question type word is going to equate to
You never know what you're going to get.
a variable, like y or a or any letter, x, usually x. Okay? Any verb or action term is going to convert to equals. And of or on converts to multiplication.
Allow me to demonstrate.
Okay, we did a couple. It's a question, it's a variable, is equals. This one's already in math language. Of is times. 4550, already in math language. And now we just compute, okay? Let's see. 6%, I'm going to have to make it into a decimal. And then do my multiplication, and I've got an answer.
Hey, this is great, man.
Not so bad if you use those conversions.
Uh-oh.
How about this one? When they're asking for a percent, it's the same deal. What becomes x? Of course, percentage is already in math language. On multiplication. 70 is already in math language. Equals. And any number is already in math language. Now, this one we're going to have to solve. We have to get x alone. Let's get rid of the 70 first. Do your division. I'm assuming you know how to do that now. Okay, now we got to say what percent is 15/100ths. Now you really have to know your definition of percents.
Wait a minute.
Percent means what out of 100. Well, that's 15 out of 100. What out of 100? It's like who's buried in Grant's tomb? The answer 15%.
Baby, you're the greatest.
Okay, so these conversions are going to help me win all these problems.
Now what am I gonna do?
Okay, let's do one more. Already in math language is. Most of this is already in math language. Of. And what number? And all we have to do now is get x alone. Now, let's convert 75% to a decimal. And now get x alone. We divide both sides. And doing your division, you got an answer. X is 416. So these conversions are not that difficult.
Excellent.
Got the idea?
Oh, I can't take it anymore.
I know, it's been long enough. Okay, that's enough for today. But you know what? I got some news for you.
Code Red, repeat. We are at Code Red.
You distance learning students, you know what time it is? I know, it's time to...
Oh, good.
It's time to take a test, okay? So, go to the assessment center. Hey, make sure you send me your homework first, and make sure you do the practice test. Go to the assessment center, okay, and take the test. Now, go out there and are you going to study your homework? You know, study your homework. You pick up the pencil and do it, okay? Now, if you have any trouble, don't forget, you can always get in touch with me, or you can use the homepage at www.montgomerycollege.edu/pre-algebra. And please don't be afraid to email me at bwitte@mc.cc.md.us. Okay? Good luck on that test. Make sure you do your homework. And thanks for listening. Thank you. Thank you very much.